Hi guys, today's lesson we're just going to be doing a couple math boxes. So this is page 268 in Math Journal Volume 2. It should be math box for lesson 711. So for number 1, it says use a common denominator to divide and then show your work. That's not a method that we worked on too much. We talked about keep, change, flip. So see if you can figure out the solution for A and B on number 1. So go ahead and pause the video and remember to keep your first number, change your division to multiplication, and flip your second number. Okay, if you have unpaused the video, hopefully you found the solution here was 28. And for the bottom one, it was 30. Just an example of how to work through, you'd keep your 7, change your division to multiplication, and that would become 4 over 1, and that's how we got 28. Okay, let's look at number 2. We're multiplying mixed numbers. There's actually 2 methods that we talked about to do that. There's what some call the box method or partial quotients, and then there's just changing both of those to improper fractions and then multiplying across. So go ahead and pause the video now and see if you can figure out the solution for that one. Okay, if you are unpausing the video and you did partial quotients or what we sometimes call the box method, this is how you could have set it up, and this is if you set it up with the numbers the same way, you would have got this inside your boxes. You would have had to add them all together and then change to have a common denominator. 10 I thought was the easiest common denominator to use. When I added them together, I got 28 and 44 over 10. I took that 44 over 10 and tried to take it from an improper fraction to a mixed number, and I found that it equaled 4 and 4/10. I could also reduce that to 4 and 2/5. But when I took that 4 and 4/10 and added it back to 28, I got a solution of either 32 and 4/10 if you didn't reduce it, or 32 and 2/5 if you did. If you did it the other method, like this, where you changed your mixed numbers into improper fractions, you should have got 9 over 2 times 36 over 5. When you multiply 2 times 5, you got 10. 36 times 9 is 324. Then I used partial quotients also to see how many times 10 would go into 324 to get this improper fraction to a mixed number. Pretty easy, this method. I knew that 30 sets of 10 was 300, so I started with that. That left me with 24 left over. 2 sets of 10 is 20, which gave me this remainder of 4. So adding these together, I got 32, remainder of 4 over 10. And then, of course, reducing it, 32 and 2/5. Okay, moving right along, let's look at number 3. Number 3 says to write an equivalent problem with a whole number divisor and then solve. So this, the 0 and 0.3 or 0 and 3/10, this is your divisor. It's the number that you're using to divide. You can never have a decimal in that number, so you have to get rid of it. And the way that you do that is basically you just move it until you have a whole number. And so, but the trick is if I moved it in my divisor, I also have to come over here and move it in my dividend the same amount of places. So if I moved it here one place, I'm going to have to move it over here one place. So my equivalent problem is then going to become 156 divided by 3 equals what? Okay, so then when you solve this problem, the answer that you get is going to be actually the answer to 15.6 divided by 0.3. So go ahead and pause the video and see if you can find the solution now. Okay, if you are unpausing the video and you did long division, it might have looked something like that. And you should have got an answer of 52. And that answer 52 is the answer to this problem, but it's also the same answer to the decimal problem above as well. Okay, looking at number 4. Number 4 says, Jory spent 1 3/4 hours doing chores. She spent 2/3 hours vacuuming. How much time did she spend on her other chores? I want you to pause the video, reread that problem if you need to, think about it, and for the first part, just write this number model. And then when you have your number model, unpause the video and let's make sure your number model is correct before you start to solve. So pause it and think about what the number model would be. Okay, if you're unpausing, hopefully you wrote 1 3/4 minus 2/3, and that's going to show us if she spent 2/3 on vacuuming, how much of the rest of the time was spent on her other chores. So remember to subtract. You do need a common denominator. So go ahead and pause the video and see if you can figure out what your solution would be for number 4. Okay, if you are unpausing the video, hopefully you found that she spent 1 1/12 hours on other chores. 1 3/4 would have become 1 9/12. And if it's easier, you could stack it on top of each other. I started to put my subtraction sign there. But 2/3 would have become 8/12. And then just subtract down. So 9 minus 8 is that 1/12 for your numerator. And then your 1 just is brought down. Okay, number 5. It says explain how you solved problem 3. So come back to problem 3. Think about what we did here and see if you can write an explanation that anybody could pick up and easily follow. Go ahead and pause the video and write your explanation now. Okay, if you are unpausing the video, I'm going to give you this example of an explanation that you can read through. Again, it's a sample, but yours will probably have some key components like that example as well. Okay, the second and last math box we're going to do today, and I know this might seem a little long, but you have no IXL and no HomeLink this week, is right next to it, page 269. We're going to do math box for lesson 712. Number 1 says to write a fraction to make each number sentence true. So all of our answers are going to be a fraction, which they reminded us by setting this up like this. The first one, 6/11 times what would equal 6/11? So obviously, to get an answer that's the same as the first multiple that we started with, or the first factor, we're going to have to find something that's equivalent to 1. So what's a fraction that you could write there that's equivalent to 1? Okay, so you could have written basically any number over itself, right? 2/2, 3/3, 4/4, whatever number over itself, those are all equivalent to 1. The only thing you couldn't do, obviously, is 0/0. Okay, part B. 6/11 times what fraction is going to give me an answer that's less than 6/11? This is where we might get a little confused. Are we going to need a fraction that's greater than 1 or less than 1? We're going to we start off with 6/11. What fraction are we going to have to put here? Is it going to be greater than 1 or less than 1 to get something now that's smaller than 6/11? Okay, hopefully you put some sort of fraction that's greater than 1. And it really doesn't matter what your fraction is as long as your numerator is more than your denominator. If it's greater than 1, then you're going to get something that's going to be less than what you started with. All right, let's look at C. Okay, I have 6/11 again, still multiplying, but this time I need to find what fraction is going to give me an answer that now is going to be greater than that 6/11. So thinking through, are you going to need a fraction? We already know we don't want a fraction that's equivalent to 1, but are you going to need a fraction that's greater than 1 or less than 1? All right, well, hopefully if you used what we've done so far, you could see that this fraction greater than 1 gave us a solution that was less than what we started with, right? So to get an answer that has a solution that's more than what we started with, we actually need a fraction that's less than 1. So any fraction you put where your numerator is less than your denominator is going to get you that result that you are looking for there. Okay, those I think can be tricky, kind of hard to visualize. Okay, let's move on to number 2. Number 2 says, write a division number sentence that matches the picture below. Your dividend should be a whole number. So this one is going to be a whole number. And your divisor should be a fraction. So this one's going to be your fraction. So look at the model that they've given you. Okay, it's not wanting you to shade anything. It's not wanting you to make anything up, but look at what they've given you. What whole number do you see? And then how did they divide that whole number? Okay, so and then think of what the solution would be. How many pieces do you have left at the end? So take a second to pause the video if you need to and see if you can figure that out. Okay, if you have unpaused the video, hopefully you counted 1, 2, 3, 4, 5 circles. You can tell each circle is divided into 1/4, and at the end, there's a total of 20 pieces. 4, 8, 12, 16, and 20. All right, almost done, guys. Let's look at number 3, and then we'll look at number 4. Number 3 says Noah bought 8.5 or 8 5/10 gallons of gas. Gas is $3.90 per gallon. How much did Noah pay for gas? So go ahead. It's always nice to make an estimate, especially with decimals, because then at the end you can see if your answer is reasonable. So think of an estimate that you could do here. Pause the video if you need more time, but if you're good to go, remember how I always said 8, anything close to 10, make it 10. You could have done like 10 times 3.9, right? You could have done that. You could have done, which 10 times 3.9 would just be 39. You could have done 10 times 4, which is 40. You could have done 9 times 4, which is 36. Any of those are perfectly fine. Look, we're all in the same range of what our answer should be. It's going to be somewhere in this area. Okay, now we got to think of how do we solve this problem. Are we doing addition, subtraction, multiplication, division? So if know about 8.5 gallons, it's $3.90 per gallon. You could either take $3.90 and do some repeated addition 8 times and then figure out what that half would be. I think that would be the hard way though. Or we could just do $3.90 times 8.5. So if you're unsure when we do this multiplication where to put that decimal, because it's different than addition and subtraction, it's not lining it up, this estimate that you did in the beginning is going to help you figure that out. So go ahead and pause the video and see if you can do that multiplication and figure out where to put that decimal. Okay, if you are unpausing the video, hopefully you got $33.15. You might have got a 0 here, but money only comes in 2 decimals. Okay, so one thing to think of too, however many places you have past the decimal, however many numbers, that's how many places your decimal goes. So if you got the answer, if you got this at the end when you did your multiplication, you would come over here and go 1, 2, 3, and that's where your decimal went. But since it's money and that 0 at the end adds no value anyways, you just knock that off and write your answers like that. Okay, hopefully you were able to come to that solution. Last but not the last problem we're going to do, I'm not going to have you do the written explanation down here, but I am going to show it to you. But the last one we're going to look at is number 4. Number 4 says, what are all the possible names for a polygon with 4 right angles and 4 equal sides? So it has to have those key components. It has to have 4 right angles and 4 equal sides. So go ahead and pause the video and read through your solution and possible answer choices and circle the best answer. So you're only circling one. Okay, so hopefully you were able to eliminate some. Rectangle obviously doesn't have 4 equal sides, even though it does have 4 right angles. Parallelogram might have equal sides, but not 4 right angles, so you could eliminate those 2 answer choices. The best choice, though, is going to be letter C, because B, although it's true, C includes many more polygons that have these qualifications, or these attributes as we like to call them. So quadrilateral, rhombus, kite, rectangle, square, trapezoid, and parallelogram all have those 4 right angles and 4 equal sides. Oh, a possible name for, okay. Because sometimes, and so this is a little confusing, because sometimes, like when you look at your hierarchy, your rhombus could be considered a rectangle, could be considered a square. Okay, so that was a little tricky. So hopefully you were able to kind of figure that out and get through what might be the best one there. All right, the 5 says explain how you found your answer to problem 1B. I think I'm going to go ahead and show you that explanation because that will help a little bit with understanding those. So let me come through and show you. Okay, so here's a sample answer for that. It says, I needed to make the left part of the number sentence greater than 6/11. So I had to multiply 6/11 by something greater than 1. And then I chose 12/7 as my answer because it's greater than 1. So if you had to explain that, that's basically all you would say. You would just say that you needed something greater than 1 and that's why you chose that. All right, folks, that is all for today. We don't have any home link or any IXL. I just want to remind you that tomorrow, Tuesday, you're going to be starting to come to school just during that afternoon time for iLearn testing. So I've put some instructions for you on Canvas of what you might need and what time to be there and where to report. And if you have any questions or concerns, feel free to email me. And if not, then I will look forward to seeing you when you're in school. I'm going to stop by and try to say hi. All right, guys, have a good week.